We have two houses here. An existing building in occupation, which is turn of the century, has an existing wet hot water system with the radiators in place, very difficult to modify or replace. We needed a conventional boiler system to provide high temperature water. The cottage, which is a completely separate building, required full renovation from scratch, and we had a clear opportunity for providing low temperature underfloor heating, which is very efficient. I wanted to use a ground source method, but on analysis that proved not satisfactory. It also requires a high input from the national grid, which we were hoping to avoid. We were hoping to use an ecological fuel. We needed a conventional boiler system to provide high temperature water, and then we had to choose between which fuel we were going to use. Oil, gas, pellet, chip, or actual wood. We were trying to avoid fossil fuels, and LPG and oil obviously are in that category. It leaves a timber product. We are getting older, and we wanted a system that we could actually manage for the next decade, not having to rely on others to undertake. So one of the design criteria was a system that was self-managing. Wood excluded itself because it's often difficult to get hold of, especially dry. The moisture content has to be reasonable, otherwise your boilers are running inefficiently. Wood chip has another characteristic of being difficult to store, and you need it in bulk because you use a lot of it. Pellet, you still use a lot of pellet, but they're much more compact. They are ideal for mechanical handling. And the result is that the wood pellet, because of its efficient burning and actual ease of management, is what came out on top for our consideration. We had a primary contractor undertaking the boiler installation, and we had a plumber and an electrician undertaking the other services. The boilers and the primary pipework took about 2 weeks to install. The secondary plumbing to link the boiler installation and the properties took about 10 days, and the electrical installation took about the same time. There was a problem with the integration of the underfloor heating system and the measurement of temperature for the boiler system. So how the thermostats controlled the boilers. It caused some anxiety, it caused some anger, and there was a financial consideration as well. We had a meeting, and the suppliers of the underfloor heating, the main contractor and the plumber, discussed the best way to rationalise the integration sort of after the contract was finished. It required stripping out some of the installed pipework, some of the methods of heat temperature measurement, and reapplying the method of control that the boilers themselves were required to have. But the system now is working very well. I had thought at the time that the method of temperature sensing for the boilers was too simple, but it does work, and it just proves that the best approach is the simple one. We have two boilers installed here, one in operation, one on standby. This boiler here is turned off at the moment, and on the right hand side the cabinet is the actual burner. On the left hand side is the silo for, as a day tank, which is supplied by vacuum tube from the main silo. This burner is situated inside the cabinet. This is the crucible where the fuel pellets are delivered through this chute here and burnt in this crucible at the bottom here. Air under pressure is blown up through the fuel to ignite it. And the whole process is an automatic ignition and automatic burning when the boiler is in operation. In this container is the day tank for pellets to supply the boiler, which are filled by the vacuum tubes. So, within this container it's full of pellets, but below that is the motor for the screw thread, which delivers the pellets from this hopper here into the boiler. For emptying purposes, that's a typical type of ash you get, and you can see it's very fine. And this is the amount of ash you'd expect in 2 or 3 weeks. This is a computer which is running the boiler. Each boiler has a similar computer, and they are linked together. This is the operating system for operation of the boiler itself. Set the boiler, set the temperature. It gives a reading for things that the boiler is doing, temperature, boiler temperature, etc. This is saying it requires cleaning in 453 hours. This is a number of hours operating, 4,410. That's a pellet consumption, 11.4 tonnes. The bulk fuel carrier, which is similar to a grain truck, reverses down the track here behind me to this point and delivers fuel via vacuum tube and blows it up into the filler point at high level on the gable end there. This construction is a 7-ton silo, timber built, and contains several months' supply of pellets. I've opened the front access here so that you can actually see the pellets. The heat requirement is high, especially in the winter months, so there is a capacity for both boilers to be on at the same time. Installation costs are quite high. We are surprised by the actual final bottom line, but you have to bear in mind that there are 2 houses and 2 completely different systems. We reckon £32,000 was good value, considering that we divide that by 2. We went through the process of looking at the requirements of a grant, but the bureaucracy and paperwork required is quite horrendous. And we were on a strict deadline for providing accommodation for my elderly parents-in-law, so we didn't go for the grant on this occasion. Old people require a high temperature all the time, so the running cost there is high. The house itself, we tend to keep the running cost down because we don't use central heating all that much except in very cold weather. We're looking at a tonne a month in the winter months and perhaps a quarter of that per month in the summer months. That giving an overall total cost of around £2,000. For 2 houses, not too bad really. I would make sure that everyone knew the requirements for the integration of the components, underfloor, boilers, plumbing, etc., and that there was a full understanding of how they were integrated. One of the criteria was that we wanted a self-managing system that was not going to require a third party to run. Pellets actually act as a liquid. They can be handled in similar ways. So it is an ideal fuel because it does actually arrive in bulk, can be handled in bulk, and actually you've got a reserve and you don't have to be constantly ordering fuel or replacing it. And unlike cut wood, which is an extremely labour-intensive process, we feel for us that this is the best solution, and I could recommend it.